Previously, we have learned about conditional probability, wherein we figure out the probability of an event A happening given that another event E has happened. If we want to figure out the probability of these two events happening, let's write it here. The probability of these two events happening here, we want to know if events A and E would affect each other's probabilities. If it does, if E affects the outcomes of A, then these events would be independent. Hence, we use our general multiplication rule that the probability of E times the probability of A given E has happened would be the probability of A and E happening. However, if the first event E does not affect, it's not the independent here. This one actually is dependent. Let's correct that. So there you go. If E affects A, rather, this is a dependent event and we will use the general multiplication rule. However, if E does not affect A, that is what we call an I don't have space, so let me just write it below here. Our independent event. Now, we're going to talk about a special type of conditional probability wherein it's not necessary that the event happened before, but the event is a new piece of information that will update our previous piece of information. Let's have an example. Suppose 70% of high school students carry cell phones. Of the students who carry cell phones, 80% also carry an MP3 player. Of the students who do not carry cell phones, 60% carry an MP3 player. What is now the probability that a randomly selected student carries a cell phone, given that the student carries an MP3 player? Pause the video and try to see if you'll be able to figure out how to solve this problem. Let's take note what we know. So 70% of high school students carry cell phones. So the probability that I will let event C be a high school student carry a cell phone is 70%. Now, we have a new piece of information. Of the students who carry cell phones, 80% of them also carry an MP3 player. So that would mean that the probability of a student having an MP3 player, given that that student carries a phone, is actually 80%. 80%. Now, of the students who do not carry cell phones, 60% carry an MP3 player. So that would mean that the probability rather of a student having an MP3 player, provided that the student is not carrying a cell phone, is 60%. So our new piece of information is that there's a 80% chance that a student carries an MP3 player provided he carries a phone, and there's a 60% chance that the student carries an MP3 player provided he doesn't carry a phone. Now, with this new piece of information, we are asked, what is the probability that a randomly selected student carries a phone, given that or provided that the student carries an MP3 player? So, with that new piece of information that we know probabilities about students having an MP3 player, what's now the probability of the student carrying a phone? Now, we know from conditional probability that the probability of event C given event M happening would be the probability of C and M happening all over the probability of M happening. Now, we can get the probability of C and M because we have the general multiplication rule. And the general multiplication rule states that the probability of C and M would then be equal to the probability of C, there you go, the probability of C multiplied by the probability of M given C. Because the event C is what we know first, so let's consider it happening first, then the probability of event M second. So, we have the probability of C, which is 70%, multiplied the probability of M given C, which is 80%, and this will give us the probability of around 56%. So we already know this value. But how about this value? The probability that a student carries an MP3 player. We only know the probability that the student carries an MP3 player given that that student carries a phone or that student doesn't carry a phone. How do we now resolve the probability of a student having an MP3 player? Let's illustrate. So let's bring down our panel a bit. There you go. And then I will draw a box. So this will represent our, there you go, students. Now, since these are in percentages, we can just let the number of students be 100, so it's easy for us to visualize. But this is just arbitrary because it's percentages. So it's easier to imagine probabilities in percentages since we know that we have a baseline of 100. There you go, I just fixed it a little bit. Now, we know the probability of a student having a cell phone, which is 70%. Just to scroll up, there you go, 70%. So let's divide our students into such a way that, let's have this one here. There you go. Where in this side here is the probability, or the event rather, that students carry a cell phone, 70%. So let's assume this is a total of 70, while the other side do not carry cell phones, so this is 30, obviously. Because if 70% carry phones, 30% do not carry phones. Now, the probability that these students carry an MP3 player provided they carry a cell phone is 80%. So that meant 80% of this carries an MP3 player. And we already know that the 80% of 70% is 56%. So let's have a 56% here. So just to represent that 56%, I'll probably have this one here. So just to roughly visualize that 56, there you go. So here, this is now the part of the students with cell phones that also have MP3 players, and that is 56. We also know this probability. The probability that a student has an MP3 player provided that the student doesn't carry a phone. It's 60%. So what we want to know is the 60% of this. So if we want to figure that out, the 60%, this is actually an original 30%, of a 30% is 18%. So that meant I need to get an 18 here. So let's erase this thing here, since we already know that what we need is an 18. Let's erase those. There you go. So let's get an 18, probably roughly just around this one here. I'll just have it here just for visualization. There. So this is our, wait a moment, I don't think that's right, because it's 18, so that's supposed to be a little bit more than half. Around here, there you go. So here, those who have MP3s, 18. with this visualization, can we now see the probability of a student having a cell phone given that the student has an MP3 player? Let's go to the next video to figure that one out.